Okay, so I want to do this video to help y'all understand how to approximate with the binomial distribution. This is an extra video outside of what we did in class. So if you're watching the video, kudos to you. You're going to get some free homework answers. Because our examples that I'm going to work with you come straight from the homework. Okay. So very quickly at the end of class today, I went over with y'all basically the guidelines or the steps to use a normal distribution to approximate binomial probabilities. So first thing we have to do is verify that we have a binomial distribution. So what's our N? What's our P? What's our Q? So just make sure it checks off all the boxes for a binomial and then get N, P, and Q. Now, just like we did with just the proportions, in order for this to be normally approximated, N times P must be greater than 5 and N times Q must be greater than 5. If they're not, we'll just have to do a normal old-fashioned binomial, which y'all struggled with miserably on the test. So I'll review that a little bit also in the video. Then let's say we say, okay, yes, we're good. We can be normal. So then our mean and standard deviation are just the mean and standard deviation of a binomial. Y'all did great on that question. And then we have to apply the appropriate continuity correction. This continuity correction is something that's going to be new. We didn't really cover it in class. That's where you add 0.52 or subtract 0.5 from the binomial probability. And that's because if we remember, our binomial probabilities show up as histograms. To where the normal curve is smooth. So we have to adjust for this smoothness. That's what we're doing here. And then last but not least, we got to do our Z calculations like we've always done, using the standard normal tables and all that good jazz. So that's what we're going to spend some time doing in this video. Like I said, my quote-unquote examples are really homework problems because you're taking the time to watch this extra video. So first one I want to look at is number 5. So they ask us to first decide whether we can use the normal distribution to approximate the binomial distribution. If we can, then use the normal distribution to indicate the probabilities and sketch their graph. If we cannot, explain why, and then use the binomial distribution. Okay, so let's see. It says a survey of adults found that 7% say their favorite sport is auto racing. So 7%, that means P is equal to 0.07, which means Q is equal to 0.93. You randomly select 300 adults. There's our N, 300. And ask them to name their favorite sport. Complete parts A through D. Okay, we can do that. So first, we have to determine if we can even use a normal distribution. So we have to check what is n times p. Well, that's 300 times 0.07, which, let's see what that gives us. That gives us 21. So are we bigger than 5? Yeah, buddy. So we're good there. Okay, then they ask us to do, or I'll say they ask us, we have to do n times q to check. So 300 times 0.93. 300 times 0.93. 279. Are we good there? You betcha. So can we use a normal approximation here? Yes, because both n times p and n times q are greater than 5. Since we've said yes, now we've got to find our mean and our standard deviation before we can even solve anything. So our mean is n times p, which we already said n times p is 21. And our standard deviation is the square root of n times p times q. The square root of 300 times 0.07 times 0.93. So if I do the math here, we're going to get 4.41928. Okay, so let's go back here and see what we've done so far. Okay, so we verified it's binomial. Check. We've determined that we can use normal. Check. We found the mean and standard deviation. Check. Now we have to apply any continuity correction. So to do that, we got to read our question, see what our question's asking. Okay, find the probability that the number of people who say auto racing is their favorite sport is at most 26. So let's say that's our x. So we want the probability that x is at most 26. So that means less than or equal to 26. Now here's where the continuity correction comes in. What we're going to have to do on this one, since we want at most 26, we're going to have to say that this, to do the normal approximation, x is less than or equal to 26.5. We can't go to 27, but remember, our curve is smooth. So we've got to adjust for that smoothness. So I'm going to mark this right here and make a note. Now this is our continuity correction. Okay. So now, once we do that, then we can, I just lost my train of thought. Once we do that, we can do our normal approximation. This is going to be the probability that Z is less than or equal to 26.5 minus 21 over 4.41928. So let's see what that gives us. That's going to be the probability that Z is less than or equal to 1 point, let's see. $1.24 is what it looks like. Okay, so now that we know our Z-score, now we can look it up in our Z table, our standard normal table, and figure out what this probability is. This is going to be 0.8925. Okay, so that's how you do that one. So our probability here, 0.8925. So now we have to sketch the graph and shade in what we were asked to find. So we can use a normal approximation. So that means we can throw D out because we can use it. 21's our mean, so we're good there. And we just want to do less than 26. So that means our answer here would be A. Which really we're doing 26.5, not 26 itself. So, okay, so that's how you do one. That's the first one we're going to look at. So we had to do our continuity correction. Then we just got our z-score like normal at that point. Okay, now number 7. So 7 is pretty much the same concept. We've got to figure out, can we do a normal approximation? And then find some probabilities. Okay, so we need to first start there. So what's our probability of success? Our probability of success is 0.38. So, whoa, hang on. Let's zoom back in. B equals 0.38. Okay, N is 12. So now our first step is to determine, can we use a normal approximation? So we have to do N times P. So 12 times 0.38, and let's see what that gives us. $4.56. Ruh-roh. That's not good. We're not bigger than 5, but let's keep going. N times Q. So 12 times 1 minus 0.38. I didn't feel like doing that in my head, so I'll do it in the calculator. It's going to be 7.44. So that one looks good, but our first one doesn't. So can we use the normal approximation here? No, because NP is less than 5. So A. So as far as a normal approximation goes, if that's all it asks us for, we would have to stop. We can't do anything normal with this. However, it says up here, if you cannot, explain why, and use the old-fashioned binomial distribution. The one y'all didn't get. So we're doing it again. So A, we're going to have to just use the binomial. We can't use our shortcut. Darn the luck, but we can't. So find the probability that the number who name professional football as their favorite is exactly 9. So we want the probability that X equals 9. Remember, we sampled 12, so we're going to have to do 12, choose 9, times our P, which is 0.38, to the 9th power, times 1 minus P, which is 0.62, to the 3rd power. So in the calculator here, this, remember, is going to be 12 NCR 9. So we run this calculation. we'll get 0.0086626. And then what's it say? Round to 4 decimal places. So the probability is 0.0087. And then they ask us to sketch the graph of the normal distribution in shade. Well, could we even use the normal distribution here? No, we had to use the old-fashioned binomial. So our answer is D. We cannot use it to approximate the binomial in this case. So if you can use it, use it. If you can't, then you just got to do old-fashioned binomial. Do it the old school way. I don't know what else to tell you. So that's about it for this video. So thank you to those of y'all that were watching, and see y'all later. Adios.